Let's take a look.
Be careful. One time, I was going to a fight and right after it started to yellow, like it was like turning yellow, so I had to slam on the brakes. So they were actually
Oh, come on.
Yeah, like I.
Oh, this is so annoying.
Yeah,
My
I
camera's
didn't know
frozen.
at first, I like slammed on the brakes, and was like doing for some man, oh my god, so I was driving, and some man was waiting in the red light next to me, and it was a red light, and we waited there for a while, and he literally starts moving, it's still a red light, so I moved a little, and then I slammed on the brakes, and I was like, what is going on? He was like in the middle of the road, and it was like a red light, and he stopped.
Why do you not like him?
No.
He's fine. I don't know, I don't like him that well, but I know like friendly, you know? You said the thing. Yeah, we
The
should
first time,
talk.
I've only worked like once or twice, and the first time it was at the Selby store.
All right, now let's see if this is working.
Yeah, that was really good, I had a really good time.
In the
And
COVID
now all
stuff.
the other things I feel like with her, still
But
back
then I don't know.
Okay, now we're in business.
Parallel parking, like, I'm so scared.
I don't even know how to do that.
I really-
No, parallel parking's so easy. Once you get it, it's
How
like.
do you do it? She told me once,
Wait,
like,
how do you do it?
So it sends like a sit back. She says like you turn like the wheel like the opposite way.
Are you driving with green light? Yeah. Okay, so what you do is you come up to the car, so your mirror is with the like, break in between the doors. Okay, and you turn your mirror all the way to the left. Back up, so then you're like,
Oh my god.
the
There we
end
go.
of the mirror line
Hot.
up with the like
Radical.
middle, the like end of
Another
the
rod.
like.
The whole.
What does that
Yeah, you
mean?
turn the
Like
wheel all the way to
not.
the other way. But as you turn it,
Radical?
you
Like,
look in the camera. As long as you don't
well,
use the
there's
camera when you're backing
slang
up, you look in
radical,
the
like,
camera,
oh,
and you
that's
go
so
until the
radical, that's so
line lines
out
up with
there.
the curb.
So
And then you turn back
wild.
around and you
What
just
does it
pull
mean
the
in the
wheel
book?
where it is and you just go
Like
all the way.
frozen and
And it pulls you in perfectly, then
I
you
have
put it
no
in drive
idea.
and drive forward.
Sorry.
I swear to God, it's the best trick ever. You have to try it. I used it on my test.
Send it.
Okay, am I ready?
Yes.
Okay.
I remember.
So, again, it would be probably helpful for you to have this little mini chart. So people on the internet,
Stop one time. I went there.
maybe you could.
People on the internet.
I'll tweet that.
I found out, did I tell you guys that I have a whole bunch of
I almost
people that
told you.
watch in the Philippines? I found out how to like do you can like click the geography.
Really?
Yes, and I have people that watch in the Philippines and, oh, where was the other
Okay,
place?
can we say hi to them?
I mean, go ahead. Hello.
Hey.
If you are not from the United States, please leave us a comment and tell us where you are.
Yeah.
Yes.
Okay, so even if you are in the United States and you're not a kid from Massachusetts, tell us where you
Or
are.
a kid or an adult, you
Comment
never
below.
know.
That's true. Could be an adult.
Or a senior citizen.
Could be.
Who knows?
Could be a toddler that's a genius. Who knows? Who knows?
Whoever you are, we love you and accept it.
All right. So here is our handy dandy chart. Just have that easily accessible,
Wait, I wonder,
so we
I
can
wonder what they think we look
take a look at these.
like. You know what I mean? Wait, I wonder what they think we look like.
Guys, all of this works the same way as it did with square roots,
Yeah.
right? So I'm still gonna do the same things that I did with square roots. So if I had two things that were under the same, that were both under square roots, I could just multiply them together and it'd be under one big square root. Same thing applies with cube roots. So I literally, as long as they're both cube roots, I can multiply them together and just have one big cube root. And now I can say to myself, I wonder if that cube root simplifies. So I would look at my chart under the perfect cubes and see if there are any perfect cubes that divide into 24. And what do you find?
2.
8 goes in, right?
Guys, 2. 8 cubed root is 2.
Right. So 8 times 3 is in fact 24. So when I split that up, cube root of 8 is just 2. And then I would leave it with cube root of 3. So multiplying those two things together actually produces this answer, fully simplified. There it is, easy peasy, right?
Yeah.
You try number 2.
Oh, that's easy.
Yeah, this one works out pretty nicely.
Okay, wait. Wait.
So just like in the last one, we're gonna multiply they're both under a cube root, so I can multiply them together and make it the cube root of just one number, in this case, 125, right? And then it just so happens, isn't 125 a perfect cube?
It is.
So my answer is it's just
Oh,
5,
Oh, yeah,
right?
yeah.
No more roots, because that literally is just the answer.
Oh, yeah, so, oh, wait, what happens to that 3 then?
Nothing. The cube root of 125 is 5, right? Because 5 times 5
Yeah.
times 5 is 125. Just like square root of 16 is just 4, right? Same idea. So let's jump to something like 6, where you've got a mix here. So be careful on 6, because they're not all the same root. So you would only multiply the ones that are the same root together. And then, so what's going to happen with this 4th root of 3? Nothing really. It just kind of stays there as part of the answer. So go ahead and try, see what you think you would do for 6. And then we'll do that together.
Okay, I think I got it. I'm scared.
So first I notice, okay, I have a cube root and a cube root, so I can multiply these two together. So that would get me the cube root of 8. And then I still have this 4th root of 3 there. Right? So did everybody do that part okay? And then cube root of 8, oh, I actually know what that is. What is a cube root of 8? It's just 2. So that's your answer. You can't go any further than that, so I'm done. Bless you. So multiplication is pretty easy. Just multiply all the things in the same root together and then simplify those roots as far as you can go. Let's talk about division. Okay, today we're going to do easy division. Tomorrow will be a little bit trickier, but it's not even that bad. So why is this easier today? Because this doesn't look that easy. If you're looking at number 7, for example. Well, the same thing applies. As long as they're the same root, I can kind of rewrite it like this, or even you could just think about it in your head. Since they're both cube roots, I can do this. Just write one big cube root with a fraction inside. And I get lucky this time because 6 divided by 3 is just 2. So this whole thing just simplifies to be that. And that's it. 2 doesn't, I can't simplify that down any further. So that's literally my answer. So you can just, as long as they are both in a cube root, I can just reduce the fraction like I normally would. So let's look at one that's a little bit more complicated, like number 8. So if I'm here, I have this 2 kind of hanging out on the outside, that's fine. So just ignore that for a second. I have both of these are under cube roots. I have a 3 and a 375. If you had the fraction 3 over 375, couldn't you reduce that fraction? Right? 375 is divisible by 3. I don't know what it is though. 125? I do know what it is. Look at me. So if I reduce this fraction, that just becomes a 1. That becomes a 125. Now, up top, right here, you're going to take the cube root of 1. What's the cube root of 1?
1.
1. 2 times 1 is just a 2. So the numerator is just 2, right? What's the denominator? What's a cube root of 125?
5.
Oh my gosh. So that whole thing just turned into 2/5. That wasn't even that bad. You try, how about 9? 9 looks good. For 9 or 8?
8.
So we reduce the fraction, 3 over 375. So reduce the fraction and then take the root. So I would do the same thing for 9, because you have these that are both under a cube root. So just reduce
Oh, yeah.
15 over 3. So the same rule applies, if you remember with square roots, we weren't ever allowed to leave a square root in the denominator. So same thing, if it's a 3rd root, 4th root, 5th root, you're not allowed to leave those roots in the denominator. But today it's kind of easy because they all don't end up with that. Tomorrow we'll see what happens when I do still have a root in the denominator. We'll see how to fix that. But for today, this right here. So I can't reduce the 3/2, so that's just gonna stay there. It's just gonna hang out there. But 15/3, I can reduce that. Doesn't 15/3, isn't that just 5? So we get 5/1. So my numerator, I can't take the third root of 5. That's as far as I can go. That's my numerator. That's all that, I can't really do anything. But the cube root of 1 is just 1. So my denominator is just 2 times 1, isn't it? So I just get 2 down there. Does that make sense? Let's try maybe one more. How about, I don't know, 12. So you've got 15 and 32. Well, let me shush so you can try it before I just go telling you things.
Wait, what was number 9 again?
So now you're doing 5th roots on 12. 12 might be easier than you think it is. Well, so if you try to attack this like we did the other problems, you might be trying to reduce 15/32. But 15 and 32 don't reduce with each other, right? So now you're like, so what am I supposed to do? But if you take a look at your chart in the perfect fifths column, you notice what?
2.
Yes.
32.
The 5th root of 32 is just 2. It's just 2. So what does that mean? That means my numerator is just going to stay the 5th root of 15. I can't do anything with that. But this really is just 2. So my denominator is just 2 times 2 or 4. And that's my final answer. That's as far as I can go. And it's perfect.
Oh.
Does that make sense?
Yes.
Okay. So there is multiplication and division, sort of. So yeah, even on the, let's try one of these trickier ones on the back. Actually, let's do 15 because that's got a negative under the cube root. So at first glance, you might be thinking, oh, do we have to deal with imaginary here? No. What's the cube root of -8?
-2.
It's just -2. Cube roots can have negative answers because -2 times -2 times -2 is -8. So right here, this cube root of -8 is just -2. So let me write my numerator, 3 cube root of 5. And then that just turns into 3 times -2, right? Because the cube root of -8 is just -2. So I just get a -6. And that's my answer. I don't even have to go any further than that. There's nothing else I can really do. Anytime you have 3 numbers, though, you should be checking, do all 3 of these have a common factor? If they did, I would reduce by that common factor, but they don't here. So that's it. That's as far as I can go there. So why don't I let you try? I would make it what? No, because this is all together as a term, right? Like if it was 2 plus 3x, you know what I mean? You wouldn't add the 2 and 3. It's the same idea because that has, yeah, 'cause these two are like attached to each other. All right. Let's talk about adding and subtracting. Let's start off easy with something like 17. What do you think the answer is to that? It works the same way as square roots did.
-1 cube root of 3.
Exactly. As long as these two things have the same roots. So it has to be the same index with the same number underneath. They are considered like radicals, just like terms. right? Like a 2x and 3x, those are like terms, I can add them together. Same thing goes here. So if I have two of these things called cube roots of 3, and I minus 3 of those same things, aren't I left with -1 of those things? So as long as my roots are identical, I'm just going to do the math on their coefficients, whatever the number is out in front. So 2 minus 3 got me that -1, and then I just keep that same root behind. Does that make sense? So you try 19. $19 is a little bit of a trick question though too. I hate to tell you. But it's all right. Okay, do I have like radicals? Sure. I have cube root of 162, cube root of 162. So all I have to do is the -3 plus 2. So doesn't that get me -1 or just negative cube root of 162? Isn't that a final answer? No. Why? It was fine in 17. That's all we did, because the cube root of 162 can be simplified. I couldn't simplify the cube root of 3. It wouldn't split up any. But there is a perfect cube that divides into 162. And I think, what was it? 27 goes in. So this actually splits into the cube root of 27 times the cube root of 6. What happens with this negative? It just comes down. That's all. The cube root of 27 is just 3. So I get -3 cube root of 6. And that's my final answer. We always have to be checking that our final answers are fully simplified, right? Like you would never give me an answer like square root of 20 because you know, oh, wait, I can simplify the square root of 20. Same thing here. So if you have something that can be simplified, you need to simplify it. Jump to number 22 real quick. And then we'll come back and try another one. So this one has 3, but it works the same way. As long as they are all literally the exact same radical, you just do the operation on the numbers in front. Ooh. You got an answer? This one ends up working out really nicely for us also. They're not all 3 the same radical, right? If you look, I have cube root of 6, cube root of 3, cube root of 6. So I can only combine the first and the last together because they're the 2 that are like radicals, not the one in the middle. But what just so happens when I combine these 2, they cancel each other out because I have a +2 and a -2, so it's gone. So my answer is just the thing in the middle. But you got to be careful, right? They were not all like terms. So you got to make sure, or like radicals. So make sure that you're looking out for that and you got to look carefully. So now having said that, let's rewind our attention back to number 21. What in the world? So you see, I have 2 that are 5th root of 4, 5th root of 4. This one though is 5th root of -4. Is that the same thing? No. But I can kind of make it be the same thing. What? Ignore everything else for a second. Let's just talk about the 5th root of -4. All by itself, 5th root of -4. You can actually simplify that. Can't I split this up into the 5th root of -1 times the 5th root of +4? Can't I do that? Right? Is it -1 times 4 still -4? So just like I split anything up, I can do that. But what is the 5th root of -1? What would the 5th root of -1 be? It's -1. -1 times -1 times blah, 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 all the way down. If you do it 5 times, it is just -1. So that this whole chunk just becomes a -1. So whenever you're taking an odd root of a negative number, you know how when we take square root and we have the negative, we would just pull it out and put the I in front?
Miss Sabia,
Yeah,
would it be a positive
no.
because there's a negative in front of it in the original problem?
Oh, yeah, but yeah, I'll go back to that.
Oh, okay.
I was just doing this all by itself. So when we were taking a square root and we saw a negative underneath, we pulled out an I, right? So anytime we're gonna take an odd index of a negative, you can just pull out a -1. So you don't really have to do this middle step. That is what you're doing, but you can just say, oh, I have a negative underneath an odd index. I just pull it out as a -1. So you can just jump right here. So in the future, if I saw something like this, 7th root of -10, let's say, I can just say, oh, that's the same thing as -7th root of +10. You can always pull out a -1 as long as that index is odd. Get what I'm saying? If it's even, you have to pull out an I.
Oh, an I.
Yeah, square root of -1 is I. So if that was an even index, right? If I wanted the 8th root of -10, that becomes I times the 8th root of 10.
That's weird.
Actually, now I'm second guessing myself because that's just square root. Now I'm not sure about this. Oh gosh, internet, don't doubt me.
No, because
Because I is just the square root of -1. So what would the 8th root be? Would be I.
I think it's fine.
Well, I guess what I'm really doing is, let me do the bit in the middle. So I'd have the 8th root of -1 and the 8th root of 10. I think I'd have I to the 8th,
Really?
right? Wouldn't I? I don't know now. Now I'm confused.
I squared it was.
What the 8th root of, I don't know now.
Wait.
I don't know. I'll have to consult my colleagues now.
This is still for like 21. Right?
Yeah, but I went way off top. Well, I made up new
Oh my
numbers.
god, I'm actually gonna go. Okay.
So anyway, we'll revisit that later. I know if it's a square root, you always pull out an I.
I
If
got
it's an
it.
odd root, you definitely pull out a -1. All right, so anyway, we're here. We just took the 5th root of -4 and we pulled out a negative. So now if I go back to my original problem, I do have that negative that's already there. So now I have negative, and now this chunk right here, we just found out was negative 5th root of 4. So just like Sam said, if I have negative, that now becomes positive. So I have 5th root of 4 here, plus the 3 5th root of 4, minus 3 5th root of 4. And then look what happens. Now they really are all the same. 5th root of 4, 5th root of 4, 5th root of 4. So even though at first glance it didn't look like I had all like radicals, I did once I simplified that one a little bit. And now that they're all the same, you probably could have noticed a lot quicker that these two just cancel each other out. So my final answer would just be the positive 5th root of 4.
Oh, because there's like the 2 negatives.
Mhm.
Okay, okay.
All right, so I think that is enough talking for today. So what do we have left? I think I would like you to just finish all the ones that we didn't do. That's not that many. Okay,
All?
yeah, yeah. Oh, you
All
guys.
of them?
Yes.
Are you serious?
Wait, can you show number 19?
Could we do like all evens or?
No, yes, you can do all evens and all odds.
Oh,
Wait, if I'm not here, why don't I just turn
I'm gonna
it?
cry.
Why don't you just, you guys have 25 minutes. You
You
can
can
do
knock it out
3
this time.
minutes worth of work at 25, I'm
Are we
sure.
doing
All of
Yellow,
them.
hey,
All the rest.
We do all. We know that.
Like even on the front?
Yeah.
Yeah.
The front and the back, all.
Oh my gosh, you guys, this is like seriously 5 minutes before.
This is like neat.
I know, it actually really is. Like, I don't even know. how to do
I'm
it.
really upset.
Oh, my goodness.
No, I'm upset. Should do something about it. Should we play
Yes.